Hello and welcome back. Our topic in this particular video is dependent and independent events. So our learning goal today, can I determine the difference between dependent and independent events and apply the appropriate strategy? So what we need to be able to do is to, first of all, we need to talk about what the difference is between the two, and then we'll talk about the two strategies involved in calculating or completing both said events. So what's the difference? First thing I have in the note, 3 examples. So if you have 2 tests next week, what is the probability you pass both? Second example, what is the probability you eat breakfast, lunch, and supper today? Finally, the third one, what is the probability you get homework in each class today? So what we're talking about, or what these 3 examples show, are what we call compound events. So compound events are events or situations that occur together. Our task today is to determine whether the first event affects the second event, affects the third event. So we're trying to determine whether the first event has an effect on the successive events afterwards. All right. So independent events. What is an independent event? An independent event is a set of 2 or more events where the previous event has no effect on later events. So if you have event 1 and event 2 interacting, and you need to ask yourself, or the question is, does the event, the first event to occur, does it have an effect or does it have no effect? So if it has no effect, you're dealing with an independent event. So that means that what happens in A will not affect the outcome in B. So looking at the example here, a coin is flipped 5 times and the result is recorded each time. Determine the probability of A part is 3 consecutive heads being flipped. Now coins, they have no memory. So if you flip the coin and you get a head and you grab the coin to flip it again, it has no memory of what it was the original time. So this is an independent, or an example of independent events. So to solve it, we go back to the probability that we previously discussed. So 3 consecutive heads. So it's the number of ways we can get 3 consecutive heads over our total number of outcomes. So we know that to get 3 consecutive heads, there's one way that occurs. What are the total possible outcomes? Well, there's 2 options the first time, 2 the second, 2 the third. So 2 times 2 times 2 is 8. So we know that there's a 1/8 probability that you will flip 3 consecutive heads. B part. What happens when it goes to 4 consecutive? It's the probability of 4 heads. Well, if we look at the previous setup there, all that's really going to happen is we are going to add on another box, and I'll use the different color green here. So there was now 4 consecutive heads. So that gets tacked on the front, and we still end up with a 1. And now this becomes a 16. So we have 1/16 of a chance. And finally, C part. Now we're looking at 5 consecutive heads. So 5 consecutive heads. The number of 5 heads, number of total outcomes, and it's going to be 1 in, multiplied by it again, 1 in 32 chance. So D part asks us to comment on the resulting probabilities. And what happens, the pattern, if you look at the pattern, an 1/8, a 1/16, a a 32nd, the probability of success gets halved every time because there's two possible outcomes, and we're looking for one specific. So the probability of success gets halved each time. And that's because due to the 50-50 chance of a head. Okay, so let's combine a couple things here. Okay, the first part is just talking about independent events. So the independent events component is this right here. Okay, can event 1 occur and then event 2 and event 3, and do they affect each other? So does event 1 affect what's going to happen with the second one? So in the case of a coin, when you flip it, okay, it doesn't change the next coin, even if you're using multiple coins, has no effect. The last part here, the last part that I was speaking to, just wanted to point out that the probability becomes more and more, or becomes smaller as you try to get, for example, 5 successive consecutive heads. So that probably decreases, the chance of success decreases as you move through. All right. Next example. So a coin is flipped and a die is rolled at the same time. So that means in your hand you have a quarter and then you have a 6-sided dice. So you shake your hand, throw it on the table, determine the probability that a head and a 5 occur. So again, we're going back to our basic probability formula here. So probability of a head plus a 5. So we need to figure out how many ways can a head and a 5 occur, and the total number of outcomes. So off to the side here, I'm going to use that pictorial process. So we're looking at 2 events. So this is I'm just going to sneak in front of that, n of h plus s. So there's 2 events. So how many ways can a head occur? Well, there's only one way. How many ways can we get a 5 on the dice? Only one. They don't affect each other. So that means that it's independent events. We do multiplication. So it's 1 times 1 is 1. Total number of outcomes. Same idea. This time it can be a head or tail. So there's 2 outcomes there. And on the dice, you have 1 through 6, so there's actually 6 options. So that means that in the combination of flipping a coin and rolling a dice, there are 12 total outcomes that could affect this situation. So that means that our final result would be 1/12 of a chance. So there's 1/12 of a chance that you get both a head and a 5 on any particular attempt. Now the next example, a die is rolled once. Determine the probability that a 3 and 6 are rolled. So 3 or 6, when we start into this question, we have number of ways of 3 or 6 over total number of outcomes. So it says here we're rolling the dice once, and hopefully there's a couple of you are thinking, wait a minute, how's this going to work? So 3 or 6 equals, if we look at it, there's only one possible roll. So when you're looking at a 3 or a 6, there's only one possible event. So if I roll a 3, I can't roll a 6. It affects the second outcome. So in this case, we cannot use independent events. Cannot use independent events here. So an independent event is when one doesn't affect the other. All right, dependent, your choice on your first event affects the second one. So the formula that's generated for an independent event is probability of A multiplied by the probability of event B. A couple other forms, and you really go with the one that you're comfortable with on the cheat sheet. So remember the union is the same as the word and. Probability of A times probability of B. And then I can also switch the right side around, because if you look above, I was really doing, in my formula, number of ways A can happen, multiplied by the number of ways B can happen, divided by the total number of outcomes. So all three of those formulas are correct. You can go ahead and you can find the probability of event A and B. You can go ahead and find that event and multiply them together. So we could have done that above. Or the method I chose to use here, I just did it in terms of number of successes. So how many ways can A happen, number of ways B. So this might be a little bit more familiar for some people because it's closer to what Unit 1 was like in finding how many ways can this occur. So that's what we were using. So that's why I tend to use that notation. It comes from doing the homework in Unit 1. All right, I have a couple more examples to go through, and I got to talk about dependent events, and that's where we'll start in the next video.